Welcome to my channel. In this session I am going to explain you some basic concepts of convolution codes. So before going into executing the convolution code problem, you want to know these basic details to execute convolution code for a given problem which is of any type of diagram. You need not afraid of the diagram, whatever it is given. You could execute the same with the simple logics if you know these concepts well. So first you need to know what is a convolution code. This is an alternative for block coding techniques which offers a high coding gain. This convolution coding is done by combining the fixed number of input bits stored in the fixed length of shift registers. This combination is done by modulo 2 addition, that is nothing but an XOR function. The operation is equivalent to binary convolution, hence it is called as convolution codes. So as I said, this modulo 2 adder is nothing but an XOR function. So example for a convolution code is nothing but which is consisting of a flip-flops, that is combination of flip-flops is known as shift registers. So it consists of a combination of flip-flops, different flip-flops which can store 1 bit memory, that is here 0 or either 0 or 1 can be stored here, and all these group of flip-flops is called as shift registers. Hence we can say how this is definition mingles with shift registers. So it adds the input bits stored in the fixed length of shift registers. So for this diagram here 3 flip-flops are given, and this is the fixed in length, and the output is produced based on the combinations of these connections. So you could see here it is connected with the M, and it is connected with M1, it is connected with M3. So the output of this Y1 is nothing but M1 XOR of M3. Whereas for the Y2 output, the addition here is given by M1 XOR of M2. So this is how the output is obtained. The output can be shifted between Y1 or Y2. This is done by the switching operation. How this performance is based on this, whether it is connected with Y1 or Y2. Some of the important terms to remember when you go for convolution codes is code rate, which is given by R. It is the ratio of K by N. K is nothing but the message bits, as we have specified in terms of linear block codes. Here K message bits produces N code word. Here also the message bit is an input and output code word is specified in terms of N. So K is the number of message bits transmitted and N is the output code word produced. So if it is given 1 by 2, if the code rate is given, convolution encoder is given with 1 by 2, you could tell it here K is nothing but 1 and how many output word bit is produced is 2. Next is code dimension. Specifying this message and code word in terms of a dimension is specified by means of n comma k. Just specifying n comma k is nothing but your code dimension in convolution codes. Next important term you should remember is the constraint length, which is specified in the capital K letter. So it tells you how much output it is produced at the shift register output. So here you could see for any number of bits, the combination of outputs produces sometimes it may be 3, sometimes it may be 2. So when we go into the problem, let me explain what is this constraint length in a clear cut. So it is nothing but how much output is produced at the shift register. Here they are specified as Y1 and Y2. For this diagram, the constraint length here is 2. The generator polynomial, next term you should remember is the generator polynomial. What is generator polynomial is? It is the output sequence obtained for each modulo 2 adder. One of the important point you should remember with the convolution code is it goes with polynomial. Hence it is easier for calculation and implementation. Next is message polynomial. Message polynomial is represented in terms of m of t. These variables might change. You should remember only the terms associated with the convolution codes. So you should remember generator polynomial, message polynomial, constraint length, then code length. Then you should specify this code rate, code dimension, etc. So coming to the message polynomial m of p, it is also based on the message sequence. How much number of message sequence? So sometimes they will specify that for this message sequence identify the output. That is what the question will be. So generally this polynomial is given by, what is polynomial? You should understand what is polynomial. Polynomial is nothing but for a given sequences how the output occurs. So generally it is nothing but the occurrence of sequence in terms of polynomial sequence for p power 0, p power 1, p power 2, p power 3 till it goes for n number of sequences, that is pn. We know p power 0 is equal to 1, hence the polynomial sequence in general can be noted as. So p power 0 it becomes 1, so it is 1. 1 into p power 1 is nothing but p, that is p power 1. 1 into p power 2 is nothing but p power 2. 1 into p power 3 is nothing but p power 3. It goes till p power n. This is how a general polynomial sequence is noted. Hope you understood these basics. In next session I will explain you with the problems. Thank you.